soil below structures should have sufficient engineering and index properties in order to resist the bearing force acting on it. However, when the soil is black cotton, it becomes very challenging for civil engineers to design the type of foundation and also the methodology in order to stabilize the soil, thereby preventing the overlying structure from unwanted settlement, consolidation and catastrophic failures. So what makes black cotton soil such terrible construction material? What element inside it is responsible for uncontrolled expansion and contraction? Why do clays or black cotton soil exhibit so much plastic properties? My name is Girish and you're watching a lecture on black cotton soil, the nightmare civil engineers are scared of. So let's start. Black cotton soil is a clayey soil which contains a mineral called montmorillonite in large proportion. To understand montmorillonite, we need to know the chemical composition and the arrangements of atoms present in it. Now, montmorillonite mineral is made up of silica tetrahedron and aluminium octahedron sheets. Before watching further, please Google about tetrahedron and octahedron shape. A self-study about these geometrical shapes will help you understand the concept very clearly. Let's understand silica tetrahedron first. In this unit, the silica atom is shared by 4 oxygen atoms. The arrangement is such a way that 3 oxygen atom forms a triangular base and remaining 1 oxygen atom is at the apex. Silica atom occupies the central space as shown in the diagram. Now, this one unit of silica tetrahedron is linked to its neighboring tetrahedron by sharing 3 oxygen atoms present at the base of each unit. This interlinked silica tetrahedron forms one silica sheet which can be represented as a trapezoid in 2D for ease of understanding. Now, in one silica unit, a silica cation has a valency of +4 and is shared with 4 oxygen surrounding it. The valency of one oxygen, as we know, is -2. Now the 3 oxygen atom forming a triangular shape at the bottom of each unit is also connected to the silica of an adjacent unit. Therefore, consider this diagram. Now, from the following diagram, it is clear that the silica atom in one silica unit is neutralized by accepting 1 electron each from 4 oxygen atom, and also the bottom 3 oxygen is neutralized by donating 2 electrons, that is 1 electron each to the attached silica. But notice that the oxygen which is present at the apex still has 1 negative charge left. Therefore, I can say that the silica sheet carries a net negative charge. Now let's talk about octahedron. In octahedron unit, there are 6 hydroxyl ions, 1 hydroxyl ions at each apex. The remaining 4 hydroxyl ions forms rectangular plane. All 6 combinedly form an octahedron shape. At the center of octahedron unit, there lies a cation which can be aluminium or magnesium. These octahedron unit link together to form an octahedron sheet. Let us represent this in the form of rectangle for ease of understanding in 2D plane. Now, when a silica tetrahedron sheet comes in contact with octahedron sheet, the negatively charged oxygen ion from tetrahedron replaces the hydroxyl ion from octahedron, thereby bonding with each other very strongly. This replacement of hydroxyl ion takes place due to the high electronegativity of an oxygen atom. Now the montmorillonite mineral has 2:1 layer arrangement, that is, one octahedron sheet is sandwiched between the 2 tetrahedron sheet as shown here in 2D diagram. This complete 2:1 layer combination jointly represent one montmorillonite mineral. Now this arrangement gives a clay a flaky like appearance which we have heard. In BC soil, you may witness many montmorillonite mineral which are joined by van der weak wall force of attraction as shown here. Now when two montmorillonite mineral come in face-to-face contact, they repel largely as the silica sheet has negative charge in it due to the oxygen. Since the arrangement of sheet is such that the silica sheet is at the boundaries and aluminium sheet is at the middle, the silica sheet of one mineral repels silica sheet of other due to the same negative charge. Therefore, this creates a gap between the minerals which are only connected due to van der Waals force of attraction. Let us write down the conclusion understood up till now. Number 1. Montmorillonite mineral has a negative charge on its surface due to 2:1 layered arrangement of tetra and octahedron sheet. Number 2. There is a minute gap generated between the two mineral sheets, which is only held to each other by Vander's weak wall force of attraction. Now, let's talk about water. Do you know water is considered as a dipolar? Let me explain. Water is made up of two hydrogen atoms and one oxygen atom. This oxygen in the molecule attracts electron much more strongly than that of hydrogen due to its high electronegativity characteristic. Therefore, the partial positive charge is established on hydrogen and partial negative charge on oxygen. Thus, it's called a dipole since it has two charges on opposite poles. We can imagine it as a bar magnet as shown here. Now, when this water molecule comes in contact with soil, I mean the BC soil, the positive side of water gets attracted and binds over the negative surface of clay particle as shown. Also, various cations present in solutions such as potassium or magnesium ions also binds to the surface of clay particle. Remember the gap between two minerals we talked just before? Yes, water enters into this gap and binds with the mineral sheet as shown. Therefore, this entry of water may increase the overall thickness of a mineral structure, making it to expand. Thus, increase in water content causes the Montmorillonite mineral to swell rapidly and reducing the water, making it to shrink. So in this way, BC soil behaves vulnerably when water is added to it due to the mineral Montmorillonite present in it. This unwanted expansion or shrinkage may cause the overlying structure to undergo settlement, giving rise to undesired stresses which may result in catastrophic failures. I hope you have understood why BC soil is known to be so dangerous. Please subscribe and press the bell icon for watching such interesting video lectures in coming days. I'm working on the quicksand concept for my next video. Till then, you can browse all the videos in my playlist and gain fabulous knowledge. Jai Hind.